All right, geometry students, so we are moving into our third type of transformation called a rotation. We should be able to recognize and apply patterns to rotate or turn points and figures in the coordinate plane. In this video specifically, we will just be talking about defining rotations and how to rotate points and figures about the origin. Make sure that you're following along with our guided notes, and let's get started. So when we talk about rotations, it is a turn around a fixed point called the center of rotation. Pretty straightforward. And specifically in this video, we're going to be talking about the patterns when you rotate about the origin. You can see in this diagram here, my center of rotation is definitely the origin. Each point is being moved, so from A to A prime, B to B prime, and C to C prime, they are being rotated the same distance around the origin. The figure rotates at a specific angle and direction. Though the figure can rotate about any fixed point, the most common center of rotation, like I was saying, is the origin. If you take a look in this diagram, I'll try to make it clear. Let's look at the rotation from A to A prime. If I draw a line from the center of rotation, which is the origin, to A, I'll draw a dotted green line here. I'll make it solid, easier to see. So I've drawn a line from point A to the center of rotation. And I'm also going to draw a line from the center of rotation to A prime. Now, if I had a protractor, I could prove this, but just know that the direction and angle of rotation is going to be 90 degrees for this figure. So you'll see, again, because we are rotating this specific amount, you can draw segments from the center of rotation to each point, and you can tell what the angle of rotation is based on the angle between those segments, if that makes sense. So here are some specific rules for rotating points about the origin. Most of the time we're going to be rotating figures counterclockwise. So when you rotate a figure 90 degrees counterclockwise, you'll notice that triangle ABC is moving from one quadrant to the other clockwise. Here's the rule. The coordinate xy is mapped onto negative y, x. So in other words, we switch our x and y values and make y negative. What's really cool about this is that a 90-degree counterclockwise rotation is the same as saying, negative 270 degrees counterclockwise or positive 270 degrees clockwise. A 180-degree rotation has a different set of rules here. We know that xy becomes negative x, negative y. In other words, change the sign of x and y. A 270-degree counterclockwise rotation, that means you're moving a total of 1, 2, 3 quadrants around. Here's the rule for that. xy transforms to y negative x. It's kind of cool. It's exactly the opposite of a 90-degree counterclockwise rotation. Notice how we switched x and y, but this time x is negative. And a 270-degree counterclockwise rotation is the same as a negative 90-degree counterclockwise rotation, or 90 degrees clockwise. So let's practice some of these rules, applying some of these rules. So we want to graph and label each figure and its image under the given rotation about the origin. And we're going to give the coordinates of the image. So in our first problem here, triangle ABC has specific vertices, and we're going to rotate it 90 degrees counterclockwise. What I want to do first is plot the points and draw my pre-image. So A is at 2, 7, B is at 6, 5, and C is at 4, 1. So we've got A, we've got B, we've got C. And here's my pre-image triangle. So when I rotate 90 degrees counterclockwise, let's recall the rule for that. Each pre-image coordinate is going to become negative yx, meaning we switch the x and y values and change the sign of the y value. So in our image, let's say we go from A to A prime. We start at 2, 7. So what we'll do is we'll switch the values and make the y value negative. So this should be negative 7, 2. B prime, same rule. 6, 5, well, we switch the values and make the y value negative. And C prime, switch the values, make the y value negative. And let me plot this image. Negative 7, 2. Here's A prime. B prime is at negative 5, 6. And C prime is at negative 1, 4. Here is my image triangle. And you'll notice that for any 90-degree counterclockwise rotation, if your pre-image is in the top right quadrant, our first coordinate, we're going to be moving into the next quadrant. We're going to be rotating 1 over. One more example. Square PQRS with these vertices rotated 180 degrees about the origin. Let's plot my points. P is at 2, 6. Q is at 6, 5. R is at 5, 1. And S is at 1, 2. Here's my lovely square. And if we're rotating 180 degrees, either direction, doesn't matter if we're rotating clockwise or counterclockwise, it'll be the same angle. It's a straight angle. That means we're taking the coordinate x, y and making it negative x, negative y, just changing the signs of the points. So our image points, P would be negative 2, negative 6. Q would be negative 6, negative 5. R prime would be negative 5, negative 1. And S prime would be negative 1, negative 2. You notice all of the pre-image points were positive values. All of the image points are going to be negative values. So P prime is at negative 2, negative 6. Here's P prime. Q prime is at negative 6, negative 5. R prime is at negative 5, negative 1. And S prime is at negative 1, negative 2. So here is my square. Not the best drawn squares, but you get the idea. All of the pre-image points have been rotated exactly 180 degrees about the origin. Here's just a visual here. If I look at the angle from point S to the center of rotation here, and the angle of S prime to the center of rotation, you'll notice I'm rotating 180 degrees about the origin. I'm rotating 2 quadrants worth. For additional practice with this skill, make sure that you are trying out some of the problems within 3 through 8. So that is our lesson all about rotations. Make sure that you're trying out the additional practice problems. Check your answers with mine in the filled in notes and ask for support if you need it. Thanks for watching. Have a great day.